or the denominator are polynomials. So for example, the fraction 2x plus 1 over x minus 2 is a rational expression. They're also referred to as algebraic fractions. So one thing about them is that as a function, they might not be defined for all of the x values. So for example, if I write it as a function f of x equal to 2x plus 1 over x minus 2, this is a function, and it's not defined for all of the x values because in a fraction, the denominator cannot be 0 because division by 0 is undefined. So I can say that any non-zero number over 0 gives me plus or minus infinity, which is undefined. Any non-zero number over 0 gives me plus or minus infinity, which is undefined. So, for example, in this fraction, for x equal to 2, I get, let's say, f of 2. I get 2 times 2 plus 1 over 2 minus 2. And this is 5 over 0, which is positive infinity, and that is undefined. So for x equal to 2, this function is not defined. So the domain of this function is any x value but 2. So we can write it as x not equal to 2. There are also other ways to write this, but the main thing is to know that this function does not have 2 in its domain. Alright, so we said that for this function f of x equal to 2x plus 1 over x minus 2, whatever makes the denominator 0 is not in the domain of the function. So the domain of the function is all x such that x is not equal to 2. So these points on the graph show themselves as vertical asymptotes. So, and that is because the graph of the function gets closer and closer to that point, but does not have any y value on that specific point. So x equal to 2 is an asymptote for this function. I'm going to show that on the graph to you in a second. Alright, so this is the graph of f of x equal to 2x plus 1 over x minus 2. Notice that, for example, x equal to 3, which would be something around here, we have a y value, which is 7, but as we get closer and closer to x equal to 2, we don't have any corresponding y value. So for x equal to 2, there's no output because it makes the function undefined. So instead, I have this vertical line at x equal to 2, which is the vertical asymptote. Okay, so let's look at another example here and try to find its domain. F of x is equal to 1 over x squared minus 6x plus 9. So to find its domain, I have to, this is a fraction, this is a rational expression, so I have to find at what points this function is undefined. So I set the denominator equal to 0 to find those points. I have x squared minus 6x plus 9 equal to 0. And this is a quadratic equation, so let's factor it out. Two numbers that when we multiply them we get 9, and when we add them we get negative 6. It looks like negative 3 and negative 3, right? So, and these two are the same, x minus 3 times x minus 3, so I can write it as x minus 3 squared equal to 0. And at x equal to 3, this quadratic equation is 0. So when I plug in 3 here, when I have f of 3, I get 1 over 0. And remember, any non-zero number over 0 gives me an undefined value. So in the domain of this function, I do not have x equal to 3. Okay, so the domain of the function is x such that x is not equal to 3. So all real numbers but 3. We're going to look at this, we're going to look at the graph of this function in a second. Alright, so this is the graph of 1 over x squared minus 6x plus 9. And this is a bit different from the graph of the previous example, and we can actually get this graph by plugging in numbers before and after the asymptote, which is x equal to 3, to kind of guess how the graph looks like. But for now, we're just using graphing tools to visualize how this looks like. So this line is at x equal to 3, and this is not actually a part of the graph. I just have this line for you to see that what actually happens. And it looks like that for greater y values, it's going to touch this. The graph is going to touch this line, but it would never touch this line because this is not a part of the graph, and that's what asymptote means. So as we get closer and closer to x equal to 3, but we never get to that point actually, and we don't have any y value for x equal to 3, so we don't have any output for that point. Alright, so I have this function f of x equal to 3x over x squared plus 2x minus 15, and the directions are to find the domain. So whenever we talk about the domain, we have to write the fraction as a function, so that's why I'm writing it as f of x equal to that. So to find the domain, I see that it's a rational expression because I have polynomials in numerator and denominator, so I go directly to the denominator and set it equal to 0 to see at what points the denominator is 0 and exclude those points from the domain. So x squared plus 2x minus 15, I set it equal to 0. And to solve it, this is quadratic equation, so I have to factor this out. Two numbers that when I multiply them, I get negative 15, and when I add them, I get 2, positive 2. So it looks like x plus 5 and x minus 3 equal to 0. So for this to be 0, x plus 5 is 0, which gives me x equal to negative 5, or x minus 3 is 0, which gives me x equal to 3. So this means that at negative 5 and 3, the denominator is 0, and those 2 points make the function undefined, so they're not in the domain of the function. So the domain of the function is all x such that x is not equal to negative 5 and 3. Alright, so I have this function g of x equal to 4x plus 4 over 2x squared minus 32. This is for you guys to try, so go ahead and pause the video, try to find its domain. We'll go over it together. Alright, so to find this function's domain, we have to set the denominator equal to 0 to see at what points this function is undefined, and then exclude those points from the domain. So 2x squared minus 32 equal to 0. I add the 32, I get 2x squared equal to 32, and divide both sides by a 2, I get x squared equal to 16, and when I take the square root of both sides, I get that x is equal to negative 4 or positive 4. So this means that for those two x values, this function is undefined because I get a number over 0. So the domain of the function is all x such that x not equal to negative or positive 4. Alright, so let's look at this example. H of x is equal to 9x minus 18 over 25 plus x squared. So to see at what values this function is undefined, I set the denominator equal to 0. 25 plus x squared equal to 0. If you think about it, x squared, if I plug in any number for x here, when I square that number, I get a positive number. And then when I add the 25 over, I get still a positive number. So this cannot be 0. This is not equal to 0. And even if I plug in 0 for x, I get 25 plus 0, and that's and that's 25. That's still not 0. You might guess that for -5 or +5 this might be 0, but let's check that. So that was for x equal to 0. Let's see, x equal to 5. It's 25 plus 5 squared, which is 25 plus 25, which gives me 50. Or if I plug in -5, I get 25 plus -5 squared, and -5 squared is +25, so again I get 50. So this denominator for any x value wouldn't be 0, so the domain of the function is all real numbers. Alright, so for this example you can also think about it this way. So if I have 25 plus x squared equal to 0, to isolate the x, I subtract the 25, and I get x squared equal to -25. And a number squared cannot be a negative number, so this is not true, and this is not true, so the denominator wouldn't ever be 0.